Hello everyone. So today we're going to go over section 4.5, word problems with polynomials. So some word problems can be modeled using polynomial functions, similar to maximum minimum problems with quadratics. So whereas most of such problems were solved by completing the square, the polynomial problems we're looking at today will be solved by factoring. So let's look at example 1. It says here 3 consecutive integers have a product of negative 210. So first step is to write a polynomial function to model the situation. Suppose the first integer is n. Then the second integer will be n plus 1. Since the 3 integers are consecutive, and of course the third integer will be n plus 2. So then we'll simply have negative 210 is equal to the product of these 3. So n times n plus 1 times n plus 2. Right, so that is the setup. Now, to find the 3 integers by factoring, we'll have the following. So negative 210 is equal to n times n plus 1 times n plus 2. Going to expand the right-hand side, so we have n times n squared plus 3n plus 2. And follow that up with n cubed plus 3n squared plus 2n, and that will be, of course, equal to negative 210. So then we can move the constant to the right-hand side, and we have 0 is equal to n cubed plus 3n squared plus 2n plus 210. Okay, so in order to factor this polynomial, we can try something like, let's try, of course, there's a lot of different numbers to try here. If we're looking at the integral zero theorem, any factor positive or negative of 210 is a possibility. To make things go a bit quicker, we're just going to try, sorry about that, n plus 7. At the very least, since we know that the 3 consecutive integers have a negative product, the integers themselves must have been negative. At least one of them. Well, either one of them was negative or all 3 of them were negative. Okay, so we try to substitute in negative 7. We have negative 7 cubed plus 3 times negative 7 squared plus 2 times negative 7 plus 210. And that's equal to, let's see here, negative 343 plus 147 minus 14 plus 210. And that is in fact equal to 0. So of course then the next step in factoring is to divide using synthetic division. So in this case we have the coefficients 1, 3, 2, and 210. And on the left-hand side, we simply have negative 7. So 1, and then negative 7 times 1 is negative 7. The sum in the second column is negative 4. And then we have a product of 28. The sum there is 30. And then, of course, that will give us negative 7 times 30 is negative 210. So that will give us a remainder of 0 as we expect. So then we're left with the trinomial n squared minus 4n plus 30, which can be factored. That would be got to be factored. Okay, I guess there's only one way to find out is to use the quadratic formula to find out if this is in fact factorable. So we have here n is equal to negative b, so negative 4, plus or minus b squared, so negative 14, sorry, negative 4 squared, minus 4 times a, which is 1, times c, which is 30. And then we take the square root of this portion here. Oops, sorry about that. And all over 2a. So this is once again the quadratic formula, right? So we have the components negative b plus or minus the square root of b squared minus 4ac all over 2a. And we'll notice right away that the part that's underneath the square root sign is less than 0. So this has no roots. So what that means is negative 7 is the only solution here. So if n is negative 7, then the second integer is n plus 1, which is negative 7 plus 1, and that is negative 6. And then finally, the third integer is negative 7 plus 2, which is negative 5. And if we check the product of negative 7 times negative 6 times negative 5, that will in fact give us negative 210. Okay, so that's the first example. Second example, the specification for a cardboard box states the width must be 5 less than the length, 5 centimeters less than the length, sorry, and the height must be double the length. So you can write an equation for the volume. V is equal to length times width times height. And it is stated that the width must be 5 less than the length, and the height is 2 times the length. So what this allows us to do is write the volume in terms of length only. So we have length times length minus 5 times 2 times length. So if we are to simplify that, this would be 2 length cubed minus 10 length square. Okay, what are the dimensions of a box with a volume of 384 centimeters cubed? So that will be 384 is equal to 2L cubed minus 10L squared. Solving this for L allows us to find the width and the height as well. So of course here we can divide both sides by 2, so that will give us 192 is equal to L cubed minus 5L squared. Similar to the previous example, we can move the 192 to the right-hand side. We have L cubed minus 5L squared minus 192 is equal to 0. Again, similar to the previous example as well. Again, there's a lot of numbers to try here because 192 has a lot of factors. Okay, So to save some time, I'm just going to try the one that works. We're going to try L minus 8. So that will be 8 cubed minus 5 times, 8 squared minus 192. 8 cubed is 512. 64 times 5 is 320 minus 192. Of course, that's 0. So therefore, just like in the previous example, we have found one factor. In this case, L minus 8 is a factor. Okay, so once again, we can divide, just like in the previous example. What's the next color here? I guess this will do. Set up the division. We have 8 on one side, and then on the other side we have 1, -5, 0, and -192. And the reason why 0 is there, we have 0L. It's important to remember to have the 0 there. The 1 carries downwards. 8 times 1 is 8. The sum in the second column is 3. 8 times 3 is 24. Sum from the third column is 24. And finally, 8 times 24 is 192. So we do have a remainder of 0. And of course, then the quotient is going to be L squared plus 3L plus 24. Now, just like in the previous example, we can also look at the quadratic formula, but we really just need to look at the part underneath the square root sign. So that's b squared minus 4ac to check if there's other roots in the first place. So in this case, we have b squared, which is 3 squared, minus 4 times 1 times 24. And of course, that will be less than 0. So there are no roots in this part. So what this tells us is only 8 is going to work. So that is to say the length is 8 centimeters. The width will be 5 less than the length, which is 3 centimeters. And the height is twice the length, so that will be 16 centimeters. And the product of these three numbers is going to be 384. Okay, so let's look at another kind of area question. Slightly different setup. Example 3, boxes of candies are to be constructed from cardboard sheets that measure 36 by 20. Each box is formed by folding a sheet along the dotted lines. What is the volume of the box as a function of x? Okay, so once again, because we're looking at volume of a box, this would just be length times width times height. Okay. So in order to make this make more sense, we have here, let's say this would be the length of the box. Second measurement is the width of the box. And finally, when the box is folded, x is the height. So let's write those letters down. So this will be, once again, the length, the width, and the height. So what we'll notice right away is that 36 is equals to 2x plus 2l, right? Because this is also the length. So altogether, we have x plus l plus x plus l for or 36 total. The width is similar. 20 is equal to 2x plus the width, w. And finally, the height is just x. All right, so this could be simplified a little bit. We want to write the volume of the box in terms of x only. So starting with the length part, 18 is equal to x plus L, dividing both sides by 2. And so the length is going to be equal to 18 minus x. You can do the same thing with the width as well. W is going to be equal to 20 minus 2x. And of course, h is just equal to x. So going back to the setup of length times width times height, we now have v is equal to 18 minus x times 20 minus 2x times x. Okay, so if this were all multiplied out, then v is going to be equal to 360 minus, see, 56x plus 2x squared times x. So v is equal to 360x minus 5x squared plus 2x cubed. All right. The next part asks what are the possible whole number dimensions of the box if the volume is 512. So essentially what it's asking is to solve the equation if we let v equal to 512. So 512 is equal to, let's rearrange terms slightly. We have 2x cubed minus 5x squared plus 360x. So this will be equal to 0. If we move the 512 to the right-hand side, which we'll do in this next step. Oh, that's not 5. This is not 5. Oh, mistakes were made. Sorry about that. I'm sure some of the viewers must be like, this doesn't make any sense. All right, so let's erase all that. It wasn't 5x. It was wasn't even close. It was 56. Let's see here. We have negative 20, and then 2 times 18 is 36. Yeah, so negative 56. All right, so that's better. Makes this question solvable, otherwise it doesn't really work. All right, x squared, 2x cubed here. All right, and then next part, 56x. Oh, sorry about that. Oh my goodness. Yeah, you just. All right, so this will be minus 56x squared, and then plus 360x, and then minus 512. And of course, each of the term can be divided by 2, so it's going to go ahead and do that here. So we have x cubed minus 28x squared plus 180x minus 256. So again, similar to the previous examples, I'm just going to try a number that works. So let's try x minus 2. So in this case, we have 2 cubed minus 28 times 2 squared plus 180 times 2 minus 256. And and that will give us 8. And then 4 times 28, which is 112, plus 360, and then minus 256. All right, so of course that will be equal to 0. So therefore, x minus 2 is in fact a factor. All right, so from there, we just need to divide. Let's go ahead and do that. The polynomial by x minus 2. So once again, we'll be using synthetic division, so 2, and then on the other side we have 2, sorry, not 2, 1, negative 28, positive 180, and then negative 256. So of course we have 1, 2, negative 26, and then negative 52. Add together give us a sum of 128 times 2 is 256. So we do have a remainder of 0 and a quotient of x squared minus 26x plus 128. So last part is to check if we have any other solution other than x equals 2. So let's see here. Again, we can just simply check b squared minus 4ac. So that will be equal to, in this case, negative 26 squared minus 4 times 1 times 128. So unlike the previous example, 26 squared is 676. And if we subtract 4 times 128 from that, so if we subtract 512, we get 164, which is greater than 0. Okay, so that means there are other solutions for x that are possible. However, the question specifically asks for whole number dimensions only, as it says right here. And if the square root part of the quadratic formula has 164, and of course 164 is not a perfect square, the additional solution will not be whole numbers, so we don't have to worry about them as here. So finally, in the last step, since x equals 2 is the only solution, so 2 is the only whole number solution. Okay, and then we can go back. Then height, of course, is just 2, because h is equal to x. And then the width is 20 minus 2x, which means 20 minus 4, which is 16. And finally, the length was 18 minus x, which is also 16. So 16 by 16, and then the height of 2. 16 squared is 256, times 2 is 512, and so that makes sense. That is the original volume that we started with. So that's it in regards to the polynomial word problems. So quick review of transformation, just a quick refresher here. We are looking at this function y equals 1/3 and x plus 3 cubed and minus 2. So we have here 1/3, we have a 3 and a 2. So of course this was the letter A. And we have x plus 3 cubed. This was the h value, and then k is negative 2. So what this does, when a is equal to 1/3, we have a vertical stretch by 1/3. h is equal to -3. So this would be, the graph would be left 3 spaces, move left 3 spaces. And k is -2. So the graph is moved down 2 spaces. Okay, so that's it for word problems. So that's it for today. So thank you for listening.